Let's do an example of estimating a quadratic regression. Here we have some data on NBA players and their statistics during the 2019-2020 season. In this data, we have information on their points, number of games, and also their age. What is the effect of age on the number of points scored if we use the quadratic functional form? So let's go to our studio and do this estimation. This data is on Nexus if you want to follow along. And I'm going to load the tidyverse package. I'm going to load the NBA data. You see I have 650 players and 30 variables, including points, games played, and how old the players were. I'm going to need to create a new column, age squared. I do that using the mutate function. I mutate the NBA data frame that I just created. The new column is called age squared, and it's equal to age times age. So if I run that using Control Enter, now I have 31 variables. And I estimate a regression with points, total points scored during the season as a function of age and age squared using the NBA data frame. The summary of that regression is right here. There's the intercept. Slope is 84 on age, and on age squared it's a negative 1.39 roughly. So let's see if we can answer the questions. So let's actually write down what we learned here. We learned that our estimate of beta 1 had the coefficient on the linear term was 84.96. The estimate on the quadratic term was negative 1.39. And we're estimating a regression of points on beta 0 plus beta 1 age plus beta 2 age squared. With a quadratic functional form, we know that we are fitting a parabola through the data points. Here, age is the independent variable, point is the dependent variable. Is the parabola facing up or facing down? We need to look at the sign on of the coefficient on the quadratic term. The sign is a negative, meaning that the parabola is facing down. When the sign on the coefficient on the quadratic term is negative, the parabola is facing down. So we're looking for a maximum. So there's going to be some relationship where at first age makes you better, and then at some point it reaches a maximum and then it declines. And so we want to find out where that maximum is. So age max equals, and we know what the formula is. It's the negative of beta 1 divided by 2 times beta 2. I'm going to write it down. Negative of beta 1 divided by 2 times beta 2. So that gives me a negative 84.96 divided by 2 times negative 1.39. When I calculate this, putting it in a calculator, I get about 31. So the maximum points are reached at age 31. So the relationship between age and athletic performance measured by the number of points is quadratic here. And it's such that at first, as you get older, you get better and better, but then after reaching the age of 31, your athletic performance in terms of number of points starts to decline. Okay, what is the expected score or expected points scored for a 20-year-old? So we can certainly calculate that. So expected points given that age equals 20. You can just plug that into our equation. So we need beta 0 plus beta 1 times 20 plus beta 2 times 20 squared, which is 400. So I need to actually pull up again beta 0. I didn't record what that was, so let me flip back into our Studio Cloud. Beta 0 was a negative 847. Negative 847, let's remember that. So I have negative 847 plus beta 1 was 84.96 times 20 plus beta 2. Well, that was negative. So put negative 1.39 times 400. And when I do that calculation, I get, let me actually do that on my phone, and I should get about 295. So 295. So a 20-year-old is expected to score about 295 points. What about a 41-year-old? Well, if you do the math, you get roughly 300. So 40-year-old and actually a 41-year-old and a 20-year-old are expected to score roughly the same number of points, which is not surprising because we see that the relationship is quadratic. And so here, somewhere here is the 20-year-old, somewhere here is the 40-year-old. In terms of athletic performance, they're roughly equal. Could you repeat the analysis using points per game instead of just points? Oh, sure, you could. Just make sure that you know how to use the function mutate, and you create a new dependent variable. Instead of points, you can create points per game, which is just points divided by the number of games. And let's see if you get different results. They shouldn't be that different. So I'll stop here. Enjoy.